Okay, I'm just sharing my screen. Yesterday we talked about binary number system. Anybody has any doubts in that point in binary number system?
No, ma'am.
Ma'am, you have called yesterday that I will join the group and
I will
share
join
the.
today morning. I had gone somewhere else. I have come
O-
back in the afternoon only. I'll join it today. Don't
okay,
worry.
ma'am. Thanks.
Today
Thank you.
only I'll join it. So we had to do about our CPU. We were talking yesterday about our CPU, right?
Yes, ma'am.
Center. So the central processing unit, we know that it is divided into two parts, that is control unit and arithmetic logic unit. Yes. So whatever processing of the PCs takes place in the central processing unit. Yeah, that means your memory or the brain of the computer is your CPU. Right, which does all the processing things is your CPU. The system's memory also plays a crucial role in processing data. Both the CPU and memory are attached to the system's motherboard. So basically, you require CPU also and memory also. So system's memory is your RAM, right? So both of them play a critical role for processing of data, and both CPU and memory are attached to the system's motherboard, right, which connects all the computer devices together, enabling them to communicate. So your motherboard is the board or electronic board, you can say, where all the components or all the devices are connected, right, and they can communicate through the motherboard only, right? So this is an example. Your RAM is your memory, and your motherboard is the board where your devices are attached, and this is your CPU, your chip. Microprocessor chip is your CPU. Right. So the central process, the control, the first part or the two main parts of the CPU are control unit and the arithmetic logic unit. So control unit directs the flow of data through the CPU and to and from other devices. That means the controlling of data and controlling of all the devices is done by the control unit. That means if it has to take input and give output, everything is done by the control unit. That it takes the data from input devices and gives you the output or returns the output to the output devices. So that it is controlling all the flow of data in the CPU. Right, and what the control unit stores the CPU's microcode, which contains the instructions for all the tasks the CPU can perform. So basically, control unit is also storing the CPU's microcode. Microcode means program or instructions, you can say, for what all tasks the CPU has to do. So all those instructions are also stored in the control unit. So what all the CPU will do is taken care by the control unit. Right. So this is the architecture. I have told you the architect of computer is John von Neumann. So this is the general architecture of John von Neumann. You have input devices, you have CPU, you have output devices, memory, and storage. Right. So CPU is CPU has two parts: control unit and arithmetic logic unit. Input devices are, or input unit, you can say, are all your input devices, and output unit will be all your output devices, which are communicating or with the control unit, and control unit is giving it to the arithmetic logic unit for processing or store. If the input has to be stored in the memory, then it passes the data to the memory unit or storage, it passes it to that. So this keeps on happening. So this is what is the architecture of your computer is all. So when we talk about the arithmetic logic unit, the actual manipulation of data takes place in the ALU. That means the calculations or changes or whatever manipulations are happening in the arithmetic logic unit. So ALU can perform arithmetic and logic both operations. So do you know what are the different arithmetic operations? Anybody knows arithmetic operations?
Multiplication.
Yes, addition, subtraction, multiplication, division, modulus is also there, right? Modulus is getting the remainder. So there are different kinds of, and what are the different logic operations?
If and or but.
No, it is and, or, and not.
Yes,
Right?
yes. Logic.
Logic operations are and operator, nor,
Or
not,
and
and
not.
nor. Right? But there are also or more operators also, like relational operators are also there, which tells the relationship between two variables, like your greater than, less than, greater than, equal to, less than, equal to, equal to. So those are also your relational operators, right? So there are different, but ALU, generally we say ALU is arithmetic and logic operations. So ALU is connected to a set of registers. I've told you, na, CPU has registers for memory, right? They are the fastest memory because they are part of the CPU.
Yes, ma'am.
So whatever is calculated, it is kept in some registers of memory. So that is your register. So ALU is connected to a set of registers, small memory areas in the CPU, which hold data and program instructions while they are being processed. Right. So they hold the data, and whatever processing is going on, they hold that thing, and that value is then passed to the control unit and given to the memory or wherever it is required. So this is what ALU does. So ALU, we were talking about, right? Arithmetic operations are plus, minus, multiply, divide. This is power. So in some programming language, this is the symbol of power, caret symbol, right? Then equal to, not equal to, greater than, less than, greater than, equal to, less than, equal to, whatever. These are your logical operations, and, or, and not are basically, we say, are your logic operations, right? So this was about your CPU, right? The two parts. Now, if we come to memory, so I have already told you two difference between memory, right, and storage. Memory is temporary, and storage is permanent. Right? And the other word is volatile. Memory is volatile. Storage is non-volatile. Right? That also, if I write it here only. So this word is most important. That is volatile and non-volatile, right? So memory is temporary or volatile, storage is permanent or non-volatile. That means memory will forget after the power is switched off, and storage will permanently keep the data even if the power is off, right? The two types of memory, when we talk about types of memory, we have two types of memory: primary memory or main memory, right? And secondary memory or auxiliary memory, right? Generally, we talk about memory. There are two types of memory: primary or main memory, secondary or auxiliary memory. Right. So primary memory are of two types: RAM and ROM, random access memory and read-only memory. And secondary memory or auxiliary memory are hard disk, floppy disk, CD, DVD, pen drive, etc. All the other memory devices are your secondary memory. Right? Do you understand?
Yes, ma'am.
Primary and
Yes, ma'am.
So when we talk about memory, we talk about RAM first, right? So RAM stores data and program code needed by the CPU. So basically CPU requires some memory where the data or program code or has to be there while running the program. So that memory is taken from RAM only. Your operating, when the system also starts, the operating system also takes some memory. That is also the RAM's memory. So the contents of RAM change rapidly and often. It is volatile memory. Read-only memory, that is ROM. ROM is read-only memory. This is non-volatile. ROM is always non-volatile or permanent. It holds instructions that run the computer when the power is turned on. When you know about BIOS, basic input output system.
Yes, ma'am.
Yes.
BIOS is your program or set of instructions which are fed into the ROM at the time of manufacturing. At the time of manufacturing, ROM has a code which lets you switch on the computer and takes the information from the ROM that this is a motherboard, this is a hard disk, this is a CD-ROM, these are the things which are in your system, and the formatting information that this kind of an operating system can be installed on this system. All the information are taken from the ROM. So that is done at the time of manufacturing. Whatever information is or program is stored inside the ROM. When the power is turned on, the computer runs and takes that instructions from there. So this is a read-only memory, ROM, right? When we talk about types of RAM and ROM, first I talk about types of RAM. If I talk about types of RAM, there are two types of RAM, static and dynamic. Have you heard about that? Static RAM and dynamic RAM? Anybody?
No, ma'am.
No. So what if the word says word is static, what does static means in English normally?
Stationary.
Yeah, stationary or stable, right? And what is dynamic?
Moving.
Moving.
Keeps on changing, right?
Yes, ma'am.
So same here in RAM. The two types of RAM I'm talking about, static and dynamic. Static RAM is the one which does not require refreshing. It keeps on working until the power is off. When the power is off, the data is gone. But until the power is on, the static RAM does not require any refreshing. The data is where whatever data is coming to it, it is storing it, right? Until the power is on. But in dynamic RAM, what is there? There are capacitors in the dynamic RAM. What does capacitors do? Like you have your refrigerator in your home, right? Or iron in your home, or geysers in your home, right? So what happens when you on the geysers or the refrigerator? After some time, the refrigerator compressors automatically switches off and automatically switches on after some time, right? To maintain the temperature. Yes or no?
Yes, ma'am.
Even the iron also, your ironing device also, what does it do? After some time, automatically the light switch goes off, and when the temperature is not at that level, it again ons itself. And same way the geyser, right? So what happens with this kind of a technology? What happens? You are saving energy, right or wrong?
Yes, ma'am.
Right. So same technology is done in the in dynamic RAM. What happens? It does not keep on working continuously. The capacitors after some time lose the charge. So losing charge, what does it help in? It helps in saving the electricity. Right. But what will happen if the dynamic RAM will the capacitors will lose the charge? That means your data will be gone. Yes or no?
Yes, ma'am.
So what happens is that in dynamic RAM, after some seconds or milliseconds, the dynamic RAM have to be refreshed after some time. So the operating system automatically refreshes it after every milliseconds or every second, right? So that's why it doesn't lose the data, but it also benefits you with the energy saving component. Right. So nowadays, generally, when you take a laptop or you buy a desktop, you generally take DDR RAM. That is dynamic RAM, right?
Yes, ma'am.
You are not taking static RAMs are also good, but nowadays, because of energy saving, we are not taking static RAMs more. We are taking dynamic RAMs. So there are two kinds of RAM, static and dynamic. Understood?
Yes, ma'am.
Yes.
When we talk about ROM, read-only memory, there are three kinds of ROM. Right. What are the three kinds of ROM? First is PROM, that is programmable read-only memory, PROM. Second is EPROM. I don't know if yeah, it is there. Types of RAM I have told you, static and dynamic. Dynamic RAM chips must be recharged with electricity very frequently, or they will lose their content. And static RAM does not need to be refreshed as often as DRAM and can hold its content longer. Right. The same thing what I told you. Right. Right. But there are another type of RAM also, which you are using it in your mobile phones or digital cameras. You know that? Those are
Yes.
known as flash memory. In your mobile phones and digital cameras, You have a RAM, which is a flash memory. It can store its content after power is turned off. So these kinds of RAM, that is flash memory, can, even after power is off, it can store the data. It is working as a non-volatile memory, permanent memory. Do you understand?
Yes.
Ma'am, if
Yeah.
they are storing data after the power is turned off, wouldn't that make them ROM?
No, in your mobile phone it is ROM, but flash memories are generally your memory devices, which you SD cards or all that you take.
Yes, ma'am.
Flash memory is used in digital cameras to store pictures, so those are generally SD cards, extra memory which you apply. In your mobile you have RAM also and ROM also.
No, I'm talking about the
Your
SD
data is
cards only.
not stored
If
in
they
RAM, it is
can keep,
your,
if the SD cards can keep data even after turning off, even when they are not connected to electricity, so wouldn't that make them ROM?
that can make them ROM, but they are a special type of RAM which can store the data even after turned off. They are a special kind of RAM. They are not considered as ROM.
Okay, ma'am.
Right. And the ROM will contain your operating system information also. ROM will contain the manufacturing time information, BIOS information also. But RAM will not contain a BIOS information. Remember that. Do you understand what I'm saying? The flash RAM, the flash memory will not contain the BIOS information. In your mobiles, your ROM is having the operating system information also inside. Right, but these flash memories will not have that. They will only save the data like an SD card.
Well, ma'am, there used to be a way to sideload Windows OS on
On
memory
what?
cards as well,
Yeah,
flash cards.
there
So
is, but
then that
that is a that is a mini thing, but that is a different kind of a thing you are talking about.
okay, ma'am.
But generally, when I'm talking about the BIOS information, that will always be on the ROM.
Mhm.
Those flash memories are special devices which have been created to keep the operating system information or operating system working also. Those are different. So there are different kinds of flash memories which have been created right now if you talk about that. But they are
Okay, ma'am.
not called as ROM, they are generally called as RAM. Flash memories
Okay.
are always RAM. Right. So these are they have shown you the RAM and ROM also. Where is RAM and where is ROM on this image? Right? So these are your RAMs. Then what are the different types of ROM? Acha, what is the right now? What is the maximum size of RAM which is there?
And
64 gigs,
64 gigs,
64.
64
please.
gigabytes.
Yes, 64 GB. And but ROM is not in such a standard. It must be in GBs or something, but not 64 GB. Then when we talk about types of ROM, I told you first is PROM, programmable read-only memory, EPROM, that is erasable programmable read-only memory, and E2PROM or EEPROM you can say, that is electrically erasable programmable read-only memory. Right. When we talk about PROM, PROM is your normal ROM only. Programmable ROM, that means that at the time of manufacturing, once it has been data is written inside that, or the program is written inside that, and when it is attached to the computer, so the system only can read the data from it. You cannot write anything inside the ROM. In your mobiles, the ROMs are readable and writable. But in the system, your ROMs are not writable. They are only programmable read-only memory. That means you can only read the data, whatever is at the time of manufacturing BIOS information, whatever is written inside the ROM, you can only read that, right, in the system. When we talk about EPROM, erasable programmable read-only memory, then erasable means that through ultraviolet rays, some companies or some atomic research or scientific research, they require that the ROM information, some information has to be changed according to their own standards. So what they want is they want erasable ROMs so that they can again reprogram it according to their own standards. So EPROM is erasable programmable read-only memory. That means you can erase the content of the ROM and again program it through ultraviolet rays. So that is EPROM. When we talk about E2PROM, that is electrically erasable programmable read-only memory. This is same as EPROM, but here ultraviolet rays is not the one which is deleting or writing the data. Here electrically the data is erased and written inside the ROM. But the technology is different, but both the things, both EPROM and E2PROM both are doing the same thing. You can erase the content and again reprogram. Right? Understood? Types
Yes,
of
ma'am.
ROM. So there are three kinds of ROM: PROM, EPROM, and E2PROM. Right. Now, one more memory is there which is known as cache memory. You must have heard about cache memory, right? Many people think that cache memory is the fastest memory. But cache memory is not the fastest memory. Registers are the fastest memory. And after registers, caches are the one which is the fastest, second fastest you can say. So cache memory is high speed memory that holds the most recent data instructions that have been loaded by the CPU. So basically what does the cache memory do is, suppose you open certain applications too often. Suppose you open Word, or suppose you open PowerPoint, you open browser, or whatever applications you are many times you open. So what does the cache do? It keeps the address or the you can say the address of that particular application inside it, data and instructions inside it, inside the cache. So when next time the CPU comes and finds, what happens is, normally what happens if you are opening some application first time, what does the CPU do is, suppose you have clicked on Word. Right. So what does the CPU say? CPU says that instruction has come that Word has to be opened. So what it goes to the RAM first, because first time you are opening it in. So there will not be any address in the cache. So it will go to the RAM. What will RAM do? RAM will go to hard disk and search for that particular application which is installed in the C drive or wherever in your hard disk, and find out that application, bring it to the RAM, and the CPU will say open it, and the application is open for you, the Word. Right. Now the first time the application is open, so the cache memory, what it will do is, it will keep the address of the location where the hard disk location where the Word application was there, and keep it inside cache. So next time when you again open the Word application, it will not go to the RAM. It will directly search in the cache that the address of that particular application is there, so it will directly open. So that's why it saves your time. So cache memory is high speed memory that holds the most recent data instructions that have been loaded by the CPU. So that is what cache do. So cache is located directly on the CPU or between the CPU and RAM, making it faster than normal RAM. So basically, cache generally is a part of your CPU. In our systems, or in normal desktops and laptops, the part of CPU is only cache. Maybe some registers are working as a cache, but in some high-end systems, separate caches are also put. So in between the CPU and the RAM, separate caches can also be put. And what does cache help you? It helps you in faster accessing the data. Right. So if the CPU resident cache, or where if the cache is inside your CPU, it is called level 1, L1 cache. And if it is an external cache, that means between the CPU and RAM it is put, then it is called an L2 cache, level 2. Right. So amount of cache has a tremendous impact on the computer speed. So how much your cache is, actually cache still is an expensive memory. So most of the time the CPU's memory is also only taken as cache's memory. There is no separate thing in our systems, but if some high-end servers or some systems require cache memory, it is still in MBs, megabits. The cache is in generally megabits, or 1 GB it must have come out. So this is the fastest memory which is there, but it is expensive. So separately you can also have it. Right? Do you understand what is cache memory?
Yes, ma'am.
Right. So like see, here in between the CPU and the RAM, the cache has been put. So this way also it can attach. Right. I just want to show you one more thing. Was unit 2, I think. So we had discussed about, we are just seeing, see, we had seen this diagram, right? The components of a digital computer, right?
Yes,
Yes,
ma'am.
Input,
yes, ma'am.
output and all that,
Yes,
right?
ma'am.
So this we are done. Computer as a data processor is okay. Then we are talking, we have seen number system also, right? Binary number
Yes.
system.
Yes.
So you can take an example from here, right? The questions must be given here. You can convert yourself. See, yeah, here it is written convert 13 to an equivalent binary number.
Just divided by 2.
Divide by 2, so you can do that. Then we had talked about ASCII and Unicode also.
Yes.
This is the ASCII table they have given you in your book. This is Doc 1, Unit 2. Then when we are talking about, then do you know what is an instruction? Anybody knows what is an instruction?
It's a set of command.
Yes. Set of commands given to the CPU that
CPU.
this thing has to be done. Right. So whatever you are writing in a program, suppose in any language, C or whatever, in any language you are writing an instruction, you're writing the code, a single line is an instruction. Right. So each instruction is comprised of two parts. Whenever you are having an instruction, which is also known as micro operation, you can say. So you have two parts. One is an opcode and other is an operand. Do you understand what is opcode and operand?
No.
Opcode is your operation code. What operation has to be done? What micro operation has to be done? That is opcode. That means you want to add it, you want to subtract it. That is micro operation. It can be logic micro operation, it can be relational micro operation, it can be arithmetic micro operation. Do you understand?
Yes.
So opcode is that code. Operation code means in binary the code of addition code, of subtraction code, of greater than code, of less than and or whatever it may be. That is opcode. What are operands? Operands are the values on which the opcode will work. Right? You have variables A and B, right? Or you have values 5 and 7. So you want to add it. So opcode means add.
And
Add
operand is 5
will
and
have a
7.
binary code and operands are your 5 and 7. Do you understand? So every instruction is comprised of two parts, that is an opcode and an operand. Right? Then only it will do something, na?
Yes.
So these things, this thing is important. So they have given you that addition opcode is this, subtraction opcode is this. They have just given that in some systems the unique opcode is this for addition and this modulus, complement, this, that. So they have given. So like if you are saying 93 plus 25, this instruction you want to say. Right? So suppose 93 is something will be there, 93 will be there in some format, I don't know, right? By convert 93, so it will give you some binary code, na?
Yes.
Right? And the addition is 000, so you can put 000 in between, and 25's conversion, binary conversion can be put. So this is how you write it. Right? So this is how it is written, basically. Then do you know what is BCD? Binary coded decimal. Anybody knows that? BCD?
A decimal written in format of binary.
Yeah, BCD is always each number. Suppose this number, if I am taking 93, I am taking 93. So each 9 and 3 separately in 4 bits I have to give. I will not take 93 as full decimal number and divide it by 2 and give you the answer. You understand? So 9, suppose 9's value is 1001. Right?
Yes.
9, I'm just giving you an example. 9 is 1001 and 3 in 4 bits I am saying, and 3 is 0011. So BCD always treats each number separately and gives you the answer.
Okay.
So here when you see 101 is 9 and 011, 011 is 011 is what? 3.
3.
So it is in BCD they have given you. Same way when you talk about 2, 2 is 0010 in 4 bits. And 5 is 0101 in 4 bits. Right?
Yes.
And the addition code is 000. See from the table above.
Okay.
Right? So this is how they have converted it in binary through BCD code. So this is BCD. This is how BCD does, not binary conversion directly. What does BCD do is it takes each digits in 4 bits. Do you understand?
Yes.
Yes.
Right?
No, ma'am.
Here, if you see here 9, 9 is 1001. If you see 3, it is 011. If you say 2, it is 0010. If you say 5, it is 0101. Separately, we are telling you. Separate numbers you have to take in BCD. Right? Well, that is in BCD, not if you do binary conversion. Right? Then they are talking about elements of CPU and their role. So CPU is your chip, right? CPU has registers. CPU is divided into control unit and arithmetic logic unit,
Yes.
right? So that is given. We have talked about that. So memory is not inside this. Here. So this is memory system, right? So I wanted to tell you about this. We have already seen. So memory, we have talked about what is the difference between memory and that, and primary and secondary. We have talked about. So primary, if you see the do you know what is access time? Anybody knows about access time?
Yes, ma'am.
What is access time?
The time taken by the processor to retrieve the data from memory location.
Yes, access time will always be equal to latency time plus seek time. We'll talk about that when we study hard disk. So access time is always latency time and the seek time. And when we study the hard disk, we'll understand what is that. So access time is actually the time taken for a particular thing to how a particular application or particular thing is accessed. How much time it takes to access that particular thing. So in primary memory it is faster and in secondary memory it is slower. Access time is slower in secondary memory. Do you understand?
Yes.
And primary memory, the storage capacity, what is storage capacity? The size of RAM or ROM will be smaller, but secondary memory have higher storage capacities. Right? How much memory you can store? The cost per bit of storage is high in primary memory. Cost is high, that is, it is expensive. And the secondary memory, the cost is low. Right? For storing a bit of data, the cost is high in primary, the cost is low in secondary. Right? So that's why if you talk about primary memory, we are saying 64-bit memory we are using. Right? 64-bit memory, 64 GB, sorry, 64 GB we are using. And in secondary memory, when we talk about hard disk, 1 TB or something we are using. Yes?
Yes, ma'am.
So capacity of this is higher, na? Secondary memory. This is smaller, 64 GB and 1 TB. So that is what the difference is. So that is also important. We should know that. Then we have talked about volatile and non-volatile also, cache memory also. Now, if we want to see the memory hierarchy, I'm just finding out where is memory hierarchy. This is your memory hierarchy. When we talk about memory hierarchy, you have registers the fastest, cache is the second fastest, main memory is the third, then magnetic disk or your hard disk or whatever it is there is your fourth, and magnetic tapes, remote access devices, what are there? They are fifth. We generally we say here secondary storage devices. Secondary storage devices are fourth. Main memory is third. Second is cache and registers are the first. So fast in fastest is what? Registers. But when we talk about storage capacity, which one has the more storage will be the secondary memory. Do you understand? The registers will have the less, will be the small, will have very the least storage capacity. You know, we were talking about that you have 64-bit processor, so if your register will be how much? 64-bit register will be there, right?
Yes, ma'am.
And when we talk about cache is in MBs, megabits. When we talk about RAM and ROM, it will be in GB. 1 GB or 64 GB or whatever it may be, and hard disk is in TBs. Pen drives are also more nowadays more 128 GB and all that has come. Right? Do you understand that?
Yes, ma'am.
So the capacity wise, secondary storage devices have more capacity and registers are the smallest capacity. But speed wise, registers are the fastest and secondary storage devices are the least faster. Right? So this memory hierarchy.
And what about the SSDs nowadays?
SSDs are also faster, na? They are also like your hard disk only. They will be faster, but not. They will be faster, but not faster than registers.
Is there any difference between hard disks and SSD?
It is. SSD is much more faster because the placement of ICs inside it is much more quicker. So data is really fast accessible rather than hard disk.
Yeah,
but it has nothing to do with registers. Registers are still the superior.
Registers are the fastest still because they are part of your CPU, and CPU is the faster. Your brain.
Not only SSD, now we have NVMe also. It is much more faster than the normal SSD.
See, why they are making the secondary storage devices a faster memory? They are changing the technology so that when you talk about the input output devices, the CPU is much faster than the input output devices. Input output devices can different devices can transfer suppose 8-bit of data at a time or 16-bit of data at a time, right? The input output devices. Same way hard disk can take this much data at a time or whatever be its capacity. So according to the CPU, what they are doing is they are making it more and more faster so that the CPU is able to access the things faster also, and the CPU and speed is a little bit measurable with the secondary storage devices and all. But the CPU will be much faster than those devices still. That means the registers will be the fastest. Right, so they are just making the technology faster so that your computer's access time decreases. How much time you need to access a particular data, that time decreases. That's why they are changing these technologies inside the CPU. So you can access the things more faster in SSDs and all that. So that's why these changes have been happening. So that is there. But you should know which is the fastest memory and which has the highest capacity. This thing you should know, whether it is the point of view of an exam or it is the point of view of an entrance exam or whatever it may be. Right, so this is what is there. See, the cost per bit also increases. The more faster the device is, the cost of that device is much higher. You understand that?
Yes, ma'am.
So that is also
Yes,
there.
ma'am.
That's why the storage capacity is less for those devices which have higher speed. Because cost per bit ज़्यादा हो जाएगा तो वो उसको कम रखना पड़ता है उनको.
Yes, ma'am. Yes, ma'am.
Right. So we have talked about that. Then I told you we have different types of technologies also in memory, like semiconductor memories are there. Semiconductor memories are your RAM and all that are semiconductor memories. Magnetic memories are your hard disks and all are your magnetic memories. Optical memories are
CD, DVD.
CD, DVD. So all the technologies of different things have different technologies, right? RAM and ROM are semiconductor memories. Hard disk is magnetic memory. CD, DVDs are optical memory. So these kinds of things are there. So semiconductor, the nature of storage is electronic, and magnetic is magnetic, and optical is optical. That is laser beam. How the memories storage is done inside that particular memory, and the access is random. Magnetic memories can be random, can be sequential. Earlier, when tape drives were there, magnetic tapes were there earlier before hard disk. So magnetic tapes were generally sequential, like your cassette. You have to listen to the first song, then only you can go to the second. You can not directly go to the second song, right?
Yes.
So magnetic memories, now hard disk is random, so you can see any, you can access any item in the hard disk, so that is there. And optical memories are also random. When you talk about volatility, so semiconductor memory, that is RAM, is volatile, right? And magnetic memories are non-volatile, optical memories are non-volatile, right? Then
Yes.
when we talk about access time, 10 to the power minus 8 in seconds is semiconductor memories, 10 to the power minus 1 is magnetic memories, and 1 is optical memory. That means this is the fastest,
Fastest.
this is second, and this is third. Right?
Mama, how about SSD, ma'am? SSD?
SSD will be near to more 10 to the power minus 3 or something it may be. I don't know exactly what is the speed of SSD, but it will be, access time will be this 10 to the power minus 3 or 4 it will be, what I guess. Right. Then semiconductor memory is the average cost or cost per bit is 10 to the power minus 2, this is 10 to the power minus 6, this is 10 to the power minus 7. That means the costliest is this one, then second is this one, and third is this one. According to cost per bit, we are talking about. Then when you say what are the two methods of accessing information, you
Ma'am,
have
what is cost here? What does it mean by the term cost?
how much cost will be required to keep a single bit of data inside that memory.
So what in terms of cost? Like cost is what? Money?
Yeah, cost
like,
is money.
okay.
Right. Now you have two basic methods of accessing information. In memory, you can access the information sequentially or serial access, you say, or directly, or you say random access, right? Right or wrong? When we were seeing here, either you could access randomly or directly or sequentially. What does sequential access means? That you one by one only your data will be read in a sequence. Whatever the sequence of data is there, that can be read according to the sequence. But what is direct and random access means?
And we can randomly access the data which has been stored.
Anywhere, any part of data, that whether it is at the 10th place or whether it is at the 4th place, it does not matter. We can access it directly. That is random access. right? So they are telling you about sequential and random access. So we just then we had already talked about this, about your smallest bit of memory and kilobyte and megabyte and byte and all that, right? We've already seen that. So this also we have seen. The main memory is RAM and ROM. There are two types of RAM, DRAM and SRAM. That is dynamic RAM and static RAM. And ROM, they are not given you the third one, but PROM, EPROM and ESCAPE-ROM. Third ROM is also there. We have talked about that, random access memory also, static and dynamic also. Then ROM also, read-only memory, PROM. So they have also here also they have given you that RAM, the category is read and write memory. This is volatile. The mechanism of writing is electrically. Eraser is also electrically. ROM is read-only memory, not volatile. And writing mechanism, one mechanism is also there, masking. Masking mechanism is there. Through this they are writing into the ROM. And not erasure is not possible in your ROM. Same PROM is also the same thing, but here in PROM you are writing electrically, right? And the erasure is not possible. Once programmed, you cannot rewrite it. But EPROM, you can electrically write, but erase using UV light, and EPROM both electrically write and erase. E square PROM, that means. So these are there. Hanji.
As you have told us, in ROM we used to store BIOS, but nowadays
BIOS
we can just update the BIOS.
No, that cannot be done by a normal user or anything. That is done by VLSI design people only. So at the time of manufacturing only they program the ROM. But there are companies or where there are scientific research applications or something like that where they have VLSI design programmers there. So they want that the ROM should be updated in their own thing or whatever BIOS information they want to change the program, so they can use EPROM and E square ROM.
Like I have a PC right now, and there's an update available for the BIOS.
See, BIOS update is a different thing. BIOS update is means that your BIOS information will be updated automatically. BIOS information can be updated. That the updates for that can be applied, but you cannot rewrite in that.
It is like that BIOS remains the same, but just to support some newly included features, it gets a little bit of attachment. So BIOS can never be writable again. It will be the same. You can just reset it to default thing, but you can't like change anything in it. It is just going to update for newer coming versions or something like that.
Some firmwares are there. Some firmware is there which gets attached with your BIOS, but it will not change your thing. The BIOS will not completely change it. Some firmware will be attached to that. So that the ROMs are not erasable. Generally, PROM and ROM are not erasable. You should remember that. Right, and in our system only PROM or ROM is only there. There is no EPROM or E square PROM. They are costly also because you require electrically erasable and UV light and all that, and they are expensive also for that.
Ma'am, will you please repeat once?
What?
What did you say right now?
What?
Will you please repeat?
I said they are expensive also because these EPROMs you require the writing mechanism electrically, and you have to write it using UV light, and these ROMs generally they are read-write mode.
Okay.
Right, so you can write it and read it, so they are expensive than this one.
Okay. Means in general PCs, they are having EPROM or PROM.
General, it is PROM only.
Okay.
Once programmed,
आवाज नहीं आ रही मैम ठीक से
आवाज नहीं आ रही है?
No, ma'am. Voice is clear.
Generally, your system will have PROM only, not E or EPROM. They will not have that because those are for special applications, not for us.
Okay.
We don't
So
require to change our BIOS. We
okay,
change our BIOS. We don't change our BIOS. No?
what we modify through BIOS
मैम
that can be done in PROM.
आवाज नहीं आ रही ठीक से.
See, if you want to change the BIOS program, I'm talking about the program. In the BIOS, you can go and change that your formatting device can be CD, can be hard disk. That you can change.
Okay.
Yes or no?
Okay.
When you format your system, don't you go to the BIOS and say that your device for accessing the formatting software can be CD or can be your hard disk, can be whatever external hard disk, right?
Okay.
So that you can change. But I am talking about the program, whole program. If you want to change, we don't change the whole program in our systems. It is once written, we will use it. That's all.
Okay, I got it, ma'am.
Ma'am, one thing as you mentioned, ROM writing mechanism is masking. What is masking? I couldn't.
Masking is a mechanism. When you go to the second semester, masking is a mechanism where what happens is in binary number system you use and or and not in binary, and how do you put the data inside that thing, that is known as masking. Right. So that you will understand later on, but there is a mechanism masking also. Now we are talking about magnetic memory. Magnetic memory, we talked about the capacity. Right? Magnetic memory is your hard disk.
Yes, ma'am.
And your magnetic tapes, which were earlier hard disks, you have magnetic tapes. So hard disk and floppy disks are magnetic disks, and magnetic tapes were also there earlier. So these are the two devices which have. So when we talk about semiconductor memories, that is RAM and ROM, they have limited capacity and volatile memory. But when we are talking about secondary memory, that is magnetic memory, that is have more capacity and it is non-volatile. Right. So when we talk about any disk or any what you say hard disk, so you have multiple disks in a hard disk. Do you know that?
Yes, ma'am.
You have multiple disks in a hard disk, and each disk, suppose you have 10 pack of 10 disks in a hard disk. So in each disk will have tracks. These are known as tracks. The circular things are known as tracks, and each track is divided into sectors. See, what is this? This is a sector, and this will be the block of data which is written on this sector. Do you understand?
Like in CDs.
Same as in CDs. So you should know what are tracks. So how many number of tracks are there? So you that will be taken care of, and how many sectors are there? That is so yeah. The number may vary. The number vary, but there are often 200 or more, ranging up to 800 is sectors per track. So basically, sectors per track are generally how much? 200 to 800 per track. Depends on the thing. So each track is here they are saying the number of tracks on the disk range up to 800. So that means your how many tracks will be there here? Circular 800. And each track is divided into sectors, normally 10 to 100. So 10 to 100 sectors may be on one track. So this is what they are telling you. So they are just talking about the hard disk. So one technique which is used in hard disk is known as Winchester technique. Hard disk contains magnetic disk, access arm. You should also know that when you are talking about the hard disk, there is a read-write head. You see, pack of disks are there, number of disks are there, and each disk there is a you can say a rod where read and write heads are attached for each disk. Read and write head. So you can read and write from each disk. So read-write heads are there. So there will be an arm. This is your arm, and this will like in a gramophone. Have you seen an old gramophone where the pin is put on the surface of the
Disk.
disk?
Yes,
The
ma'am.
same way here your read and write heads are same like a pin, which wherever you want the access or read, you want to read from there or write to that particular place, it will go to that particular place, and the write head and read head will read and write there. So same way. So the hard disk contains the arm and the read write head also into a sealed air filtered enclosure. So it is sealed inside. You cannot see the disk actually. If you buy a hard disk, can you see the disk? No. The outer container is there, na? It is sealed inside. Right. So this technique is known as Winchester technique. This technique where your disk is sealed inside, and inside it will be having number of disk and the arm, and that is known as Winchester. That technique. So I was talking about a set of corresponding tracks in all surfaces of a disk pack, that is the tracks with the same diameter on the various surfaces, is called a cylinder. That means a set of corresponding tracks in all surfaces of a disk pack. That means suppose this is the track on this and this is the track on this, the same tracks of having the same diameters on each disk is known as what? A cylinder. Can you understand what does that mean? Each disk having the same track diameter. This diameter of the track are same, na? On each disk. So these combined of each disk, the same type of diameter disk tracks. So that is known as a cylinder. So here the concept of cylinder is very important because data stored in the same cylinder can be retrieved much faster than if it were distributed among different cylinders. So, and the surface, how many surface will be there on the disk? Do you know what does surface means?
And the surface will be only on one side.
Both the side, generally on one side, but that the last disk will be not treated as that. And the surface is always n-1. So when we see this formula, you should always know. Suppose a hard disk or disk pack having n plates. N plates, what does n plates mean? Plates
and
means
the number of plates that there are in the hard disk.
N number of plates means n number of disks. Right? Suppose you have a hard disk having n plates. So M will be equal to 2n, total number of recording surfaces, 2n. 2n, what does that mean? N are the number of plates. So 2n means 2 into n. So that means
so
you can write above also, below also. You can write above the surface of the disk and below the surface of the disk also. Do you understand? What does 2n means?
Yes, two sides, ma'am. Upper and lower sides.
Yeah. So that's why M is equal to 2n, total number of recording surfaces. T is the track per surface. How many tracks are there on the surface? Right? P is equal to sectors per track. How many sectors are on a particular track? And S is the bytes per sector. How many bytes are written in a sector? And pi value, you all know that pi is 3.14, right?
Yes, ma'am.
Right. Now, storage capacity of the disk. If you know all these elements, M, T, P, S and pi, then what is the formula for calculating the storage capacity of the disk? The formula is M into T into P into S. That is the total number of recording surfaces into tracks per surface into sectors per track into bytes per sector. This will give you the storage capacity of the disk. Do you understand? How much storage capacity of the disk is? And if D is the diameter of the disk, suppose this disk has diameter is the whole this, right? If the disk diameter, if D is the diameter of the disk, then the density of the recording is, how density is calculating for the recording is S into P, that is bytes per sector into sectors per track, divided by pi into D. D is the diameter, right? So byte per inch, this much byte per inch density will be there, and this is in bytes. The memory capacity is in bytes. Do you understand the formula, both the formulas?
Can you explain as an example?
Example, we are going down only. As an example, suppose here you are given a 2.5-inch diameter disk pack has 6 plates, right? Diameter is how much? 2.5 inch. Can you see that? D.
Yes.
D is how much? 2.5.
2.5 inch.
Then disk pack has 6 plates. So how many recording surfaces? 6 into 2, how many?
12.
12. So your M is 2S. That means
12.
6 into 2, 12 recording surfaces. Then 256 sectors per track. That is P is 256. 5250 tracks per surface. That is T. Then 512 bytes per track. That is S. So thus the capacity will be how much? 12 into 256 into 5250 into 512 is your total capacity of the hard disk. Can you see that?
Yes, ma'am.
And they have converted into then GB. And when we are talking about recording density, it is your S, that is bytes per sector, 512, multiplied by sector per track, that is 256, divided by pi, that is 3.14, into density of the disk is 2.5. So this will come out to be this bytes per inch.
So will the standard be always in inches, or we can convert it?
It is generally 2.5 inch only.
Can you explain
It will generally be in inches. And what will be the storage capacity of a 2.5-inch diameter disk pack having 8 plates, 400 sectors per track, 2820 tracks per surface, where 512 bytes of data can be stored per sector? Can you understand the question? You have to calculate the storage capacity of a 2.5-inch diameter disk pack having 8 plates. 8 plates means
16 recording plates.
Right?
16, yes.
400 sectors per track. So S is this. 2820 tracks per sector. T is this. 512 bytes per sector. That is your S. So just multiply 16 into 2820 into 400 into 512. This much bytes of data will be the storage capacity. Right? Any problem?
No.
No, ma'am.
This thing I wanted to tell you, that's why I've opened the book. Right, this all of you should know. Then we were talking about access time, right? Access time. So how is access time calculated? First of all, you should know access time is the time required to access a particular item on the disk. Whose mic is there? Please mute it. So how is access time? Suppose your read-write head has to position to that particular location where your data is, and then it will read that or write that data there, right? That is what access time is. Do you understand? Your read-write head has to position itself at a particular place where you want to read or write, right?
Yes,
ma'am.
Right, and then it will find out the track, the sector, and the byte where your data is, right? So that is what is the access time. So how is access time calculated is, first you have to see the seek times. What is seek time? The time required to position the read-write head over proper track is called seek time. So you have to position your read-write head at the proper track where your data is. So first you go to the track, so that is seek time, right? And the next one is the latency time. What is the latency time? Or it is also known as search time. It's the time required to bring the needed data under the read-write head. Now your track has been found that the data is in this track. Now in that track, a particular sector and data will be on that particular sector, right?
Yes.
Right. So what the time required for that read-write head, the needed data under that read-write head, or the bytes or the sectors bytes. So that is known as latency time. So adding both the things, the seek time plus latency time gives you the access time. This is the access time. Seek time plus latency
time.
So average access time for most disk systems is usually between 10 to 100 milliseconds. Right? Only the definitions you should know. Here no calculation is required. Here in access time no calculation is required, but you should know that what is access time, what is seek time, what is latency time. And access time is equal to seek time plus latency time. That is most important. Right. Then the another secondary storage device is your pen drive. So nowadays earlier also pen drives, you have USB pen drives, yeah, universal serial bus, right? So after CD-ROMs and DVDs, pen drive became famous. So you used to carry data inside this. So they are also kind of a flash drive. They are known as flash drives also. Then you had also had earlier than a magnetic disk, that is your hard disk, you have magnetic tapes. So they were just like cassettes and you could read the data sequentially, and the storage capacity of those magnetic tapes were 220 GB to 150 GB. Here also they have given how the storage capacity of a tape drive is calculated. Storage capacity is calculated data recording density into length. How much length of the tape is. Right. If a tape length is 3,400 feet long and has a data recording density of 900 bits per inch, right, bytes per inch, its storage capacity will be 3,400 into 12 into 9. How come? Why they have multiplied it to 3,400 into 12?
The width of the tape.
Yeah, 3,400 feet it was. So we have to convert it into inches. Right, that's why they have multiplied it with 12. Do you understand?
Yeah, ma'am, got it.
So 3,400 into 12 into 900. So this much bytes of capacity of data is in for this tape drives. For this also they have given. This is your. You can always go through your multiple your. Each unit has check progresses in after every content. There is check progress question in each unit. Please answer these questions so you'll be familiar with the things which are there. There are multiple choice questions also, and there are descriptive questions also. Then you have optical memories. Optical memories, you have CD-ROM. Right? What is the earlier before CD-ROMs you also had floppy disk, right?
Yes.
So what was the maximum capacity of the floppy disk?
1.44 MB.
Yeah. And what is the maximum capacity of CD-ROM?
700, I think.
700
MB.
MB. Right. Right. So same way here also you have tracks and sectors in your CDs. Right, they have given you what are the advantages and what are the disadvantages of using a CD. Then also you also have WOM or CD recordable. Do you know about CD recordable?
I'm like CD burner.
You could a blank CD where data could be recorded once.
One time.
One time. That is CD recordable. Blank CD where once you can record a data. And erasable optical disk, that is CD reader writer. That means you could rewrite the data as many number of times. Do you understand?
Yes, ma'am.
So that is also there. Then you had DVD, digital video disc, right? CDs, compact disc. So DVD, ROM, DVD, recordable, DVD RAM. These were the things which had. And what is the maximum capacity of a DVD?
4.7 GB.
GB, yeah. So you had recordable DVDs also. That means blank DVD once recorded, and you have DVD RAM also. It is a rewritable DVD. So as many number of times you could erase it and write the data. So that is there. So they have given you different types of secondary memories and its features: hard disk, pen drive, CDs, capacity, advantages, disadvantages, uses, and storage mechanism. What are the mechanisms used for storage? So they have given you, which we have already seen. So why is memory? They are discussing about memory. Why do we use memory basically? So we have talked about this. The fastest is registers and the speed wise, and the least fastest is magnetic disk and tape. And the capacity wise, the higher capacity is in magnetic disk and tape, and the least capacity is registers. Right there, that's what they are talking about. We have already talked about that.
Ma'am, SST is in which category? Is it optical?
This is that will always be secondary storage only.
No, in which category? Is it optical or magnetic?
It's magnetic.
It's semiconductor. It's semiconductor.
Semiconductor.
Okay.
In like main memory and RAM and ROM are semiconductor, same way. Right?
Yes, ma'am.
So this was about unit 3. We had discussed yesterday for unit 4. Do you remember input output devices?
Yes, ma'am.
Yes.
Do you know what is a port?
Yes.
What is a port?
Yes.
Where you can plug.
Which we connect our devices.
Yeah.
Where
So,
attach.
Connect the input.
Through port, we can send data.
so port
from
is
one
a
device.
connecting socket outside the system into which different types of cables are plugged. Right? It is a specific place from which other devices can be physically connected. Right?
Yes.
That is your port. So there are input output ports. Different ports are there. So you have for printers, modems, joysticks, whatever different devices are there. You have different ports for them. Like you have parallel port. What is a parallel port? Various peripherals are also input output devices only. So various peripherals can be connected to parallel port, which is a parallel communication physical interface. A parallel port transmits 8 bits of a byte of data in parallel. It is used for transmitting fast data over short distance. It is used to connect a printer to a computer. So generally, parallel port, what devices can be connected, like a printer. And parallelly, it can transfer 1 byte of data, 8 bits. Right. So this is a parallel port. This. Can you see that? And this is the printers connected. Right now you don't have parallel port. You have USB connecting devices now, na?
Yes,
Printers are also
Yes,
USB connecting nowadays. Earlier it was parallel port, right?
Yes.
Now the other one is serial port. So serial port transmits 1 byte of a 1 bit of a byte. That means in 8 bits it will transfer only 1 bit. One at a time means as a single stream of bits. Like in a keyboard, what you do? You press A, then A goes to the one bit will go to that stream. So it is meant for transmitting slow data over long distance. Communication over a phone is an example of serial communication. It is a serial communication. So see, this kind of a thing was serial communication. Dial-up modems and all that. So one bit of information could go. So nowadays this is not use serial port. Now you generally have USB devices only. So this is your now normal things which you are using are your universal serial bus USB, right? So USB port can connect up to 127 peripheral devices such as digital camera, digital speakers, scanner speakers, etc. It permits plug and play configuring of expansion cards and peripheral devices as and when they are installed. So installation is also not required. They are plug and play. So your mouse, keyboard, whatever devices nowadays are generally what? USB.
Plug and play.
Plug and play USB devices. Then also you also have small computer system interface, SCSI port also. What is SCSI port is used for? It allows data to be transmitted in a daisy chain or up to 7 devices at a speed higher 32 bits at a time than those possible with serial and parallel ports. So normally hard disk and all are connected through this mechanism, SCSI. Right, so it is a fast data transmitting device and is used to connect hard disk, CD-ROM drives and scanners with the computer. Right, so that is SCSI. But nowadays the scanners are not, the external scanners are there, so you have USB only. Right, but if inbuilt CD-ROM and inbuilt hard disk will always be SCSI or some SCSI port will be there on the motherboard or something. Right. Even your external hard disk is also USB based, right?
Yes, ma'am.
So now then comes input devices. We had talked about. You can read that the keyboard and mouse we had already talked. But just I wanted to discuss about ports. What are ports? So you should know there is serial port, parallel port, USB, and SCSI. So that is there. Other things we had already discussed. Just read it. Whatever you are not able to understand in this, like we had discussed about printers, the impact and non-impact printers, and what are the different types printers. From this chapter, you may get short notes, questions like about writing about digital camera, writing about scanner, or writing about monitors, or something like that. Short notes can come from this, right? So that kind of a question can come. And when we are talking about unit 5, so we had talked about our workstation, right? PCs and workstations. So they are talking about the configuration. How do you see the configuration of your system?
I use DX.
Yes, ma'am.
You can use that also. I'm just giving you a simple example. You can go to your PC, go to properties.
Computer management.
Right. So there your device name, your processor, your RAM, right? Your operating system, 64-bit, what operating system is running. This information you will get from here also. You understand?
Yes, ma'am.
Yes.
So from the properties on this PC, you will get the things which are generally inside your system. That is one kind of information. So they are talking about your currently Core 2 Duo processors are very common, but nowadays Core 2 Duo is not there. You have i3, i5, i7, right? Intel's.
Yes, ma'am.
So those they are talking about the processors, different kinds of processors, and how is the processor speed calculated? In what measurement? What
Gigahertz.
Hertz.
Yeah, it's gigahertz. So that is there. So they are saying right click on my computer available on your PC. Select properties, go to general tab. This will give you the basic information of your computer, which I have already told you. And if you select the hardware tab, and or you can go to the device manager also. How would you go to the device manager? In Windows 10, so you can write here in the search box device manager, and you will get that.
Control panel we can go to.
Otherwise, you can also right click on manage. right click and click on manage, and it will give you the, from there also you can go. And on window R, that is run, also there is some shortcut. This is device manager. So it will give you what all components are on your systems, right? So that you can see what are the different audio input, output, battery, Bluetooth, computer, camera, whatever, keyboard, mouse, whatever devices are there, that you can see here. Then disk storage also you can see here, how much storage is there in your system, that you can see here. So C drive is taking how much, D drive is taking how much, so you can see that, right? So they are talking about workstation. Workstation can be your normal high performance computer, which can work as a you can say for scientific applications also. You can do a simple server, small network server can also be made with that. So that they are saying that the typical configuration of a workstation is Intel Core processor 3.20, memory, that is RAM is 4 GB and hard disk is 500 GB RAM. What memory they are talking about here? 4 GB and RAM is 2 GB. Maybe they have written wrongly. This is only the, when 2 GB they are saying that, but here they are saying 4 GB.
Ma'am, I guess it's total memory. It can go up to 4 GB with one stick having 133 megahertz.
Fine. So this kind of a configuration they are giving, but now more high-end systems, your own system will be much higher than this, if you see that, right?
Yes, ma'am.
So that they are talking about the old systems, but nowadays more higher-end systems have come. Then desktop computer is normal, your own desktop they are talking about. So many companies are making desktop computers. Laptops are there. Many companies are also making laptops accordingly. They are portable devices, right? So they are saying 320 GB SATA hard disk, processor P6200. But nowadays, so more higher laptops have come. Nowadays, only people are using laptops only. No desktops are used. These are notebooks or netbooks, you can say. They are special type of laptop which is very light and small. Due to its size and weight, it is very portable and one may carry it very easily. Some universities and colleges also netbooks were given earlier. Netbooks were given to the students in some universities and colleges. Right, so they have given you the configuration also, but then you have tablet PCs, right? Tablets have also come into market nowadays. So like an iPad, iPad is there the same way. So the configuration, the old configurations are only given here. And what are the different components of a CPU? They have given you. You have cabinet, you have CPU, that is your chip. Then you have motherboard. This is your motherboard. This is the image. What all back panel connectors, AGP slots, all these things are given here. We'll talk about, see there, ATX power connector. What is power connector? Connect computer's power supply to the motherboard.
Yes.
Right. AGP slot is accelerated graphic port. It's a point-to-point channel which is used to attach a video card to the motherboard, like your monitor or something like that. Right.
I mean, like a graphic card.
Yeah, like a graphic card also. CD in header address, CD drive is plugged in or connected. FDDs, floppy disk drive is connected. HDDs, hard disk drive is connected, and PCI slot, it is used for connecting PCI, peripheral component interconnect card. PCI slots are extra slots which are given to you, right? Where you can connect more components like LAN card and all that or whatever. Then you have USB headers. It is a group of pins to which an internal USB cables can be attached to provide extra USB ports. So these are there. Then you also can attach video card also, right? Video card also is there. So these are the different devices that AGP, you can attach this video card in the AGP. Then we had talked about the software part also, na? What is the software? Software is a set of programs, right?
Yes, ma'am.
So when we talk about the software, we were talking here also. So operating system is also one of the softwares. Yes.
Yes.
So there are three types of software. If in my terms, there are three types of software. One is the system software, the other is the application software, and the third one is the utility software. Right? So what are system software? System software is a set of programs which are used to run the system. The whole system is run by that software, and that system software example is your operating system. Do you understand?
Yes, ma'am.
Which is handling your running
Yes,
your
ma'am.
whole system is your operating system. The main system software is your operating system. So it is controlling all the operations of the computer, right? They are talking about if you give the definition of an operating system, what will be the definition of an operating system?
A type of software from which you can access all the components of your PC with a GUI.
Yeah, but the main definition when we talk, you are telling right, absolutely right. One of the features is this also. But when we talk about the main definition, we always say that operating system is an interface between the user and the hardware. You understand? See, can you talk to the hardware? Can you talk to the hardware directly?
No, ma'am.
Because hardware will understand binary and we don't know binary. Right. So we are giving instruction in our own language. Who is the translator? Who is interpreting our commands and interpreting our things is the operating system. So whatever whether we are clicking, whether we are typing, whether we are doing whatever, the information is gone to the operating system. It interprets it and converts it into binary and give it to the particular hardware where you want the things to be saved or your printed or whatever. Right. So basically, when we talk about an operating system, the main definition of an operating system is it is an interface, a phase between me and the hardware to communicate. Do you understand?
Yes.
So that is the main definition.
Yes, ma'am.
Other features are also there. Your operating system can do file management. Your operating system can do memory management. Your operating system can do device management. Your operating system can handle security of the system. Your operating system can do scheduling also. There are many features, right? So there are many features of operating system, but the main definition is that it is an interface between the user and the hardware. And it also acts as a bridge between application program and the computer hardware. Application programs are installed on the operating system, right? And the application program needs to interact with the hardware. Then also in between is the application program have to interact with the hardware. Then also in between is the operating system. So it is handling the input-output devices, the memory, the CPU, everything, the operating system. So that is one thing. Then the other second type of software is application software. First is system software. We talked about that is operating system. The second type is application software. So application software are those set of programs which are necessary to carry out operations for a specified applications. Like you are using Word for editing documents and all that. You are using PowerPoint for presentations. You are using a browser for accessing the internet, right? Right. So those are your, what are those? Those are your application software for doing some specific application. Then you also see there are different, you have some media players also for listening to audio and video, right? So they have given you. Do you know some extensions of the audio video files?
MP4,
Yes.
LSAC.
MKV, FWID.
MP3 were there, MP4, WMA is there.
NVEC is there.
Yeah, so there are, you should know all the extension files you should know. So there are other utility software also inside your system, yes or no?
Yes.
So the third kind I
Antivirus.
told you about is, apart from application software, the third kind is utility software. Like media player is used for listening to music or video files you want to watch, right? And
Yes.
calculator is used for your for calculating certain things. Same way, so we are just talking about that. These are application software basically. When we talk about utility software, they are generally known as utilities which help the user to maintain the system and perform routine tasks. Maintain the system, can you understand? How do you maintain a system? That means you want to format the drives, you want to scan for viruses. Antivirus is a utility software. Do you understand? You are maintaining the system now, finding the viruses, formatting the drives. Format the format the drive means you can format your drives inside your systems, right or wrong?
Yes, ma'am.
You can free up the memory also. You can check how much free memory is there and how much memory is taken by the files. Yes. So all those softwares which help you do these things are known as utility softwares. So like disk checker, system restore, disk defragmenters, disk management, backup, antivirus, disk cleaners, network utilities, data compression. These are all utility softwares. Right, so they have given you what are disk checkers. You can check the disk, the integrity of the disk is okay or not.
Yes, ma'am. Every shop, whether it is medical shop or other shop, they have a particular software for which they maintain
So
their goods or
that is
etc.
not utility, that is an application software.
Okay, ma'am. That's application software.
Yeah,
Okay.
they have created an application software for their own use for a particular task. They are maintaining the hospital management or clean whatever medicine management, whatever they are doing. So that is an application software. That is not related to the system.
Special purposes.
That is not related to the system maintenance. Utility software are related to systems maintenance, computer system maintenance. Do you understand? Medicine is not involved in any maintenance of the system, na computer system. So medicine medicine software will be application software, but these are
Yes.
generally system maintenance software which are utility softwares.
Okay. Okay, ma'am.
Right. So you have checked check this is there. So they have given you the thing. How can you check your disk? They have given you the if you want you can run that. Then you have system restore also inside your Windows 7 to 10. You have system restore also. That means the last point where you can mark a last point in your system where suppose some kind of problem has occurred in your system, so you can go back to that particular point restore point where you have marked it. So your system will be set to that default restore point you have put. That is there. They have given you that also. Then this defragmenter is there. So what does this defragmenter do is, so suppose you have number of files on your disk, but each disk is not contiguous memory locations. Can you understand what is contiguous? Means the files are haywire everywhere. Means if you see a memory space, there some memory is filled, some is empty in between, then it is filled, then it is empty in between, then it is filled, then it is empty in between. You understand?
Ma'am, not organized.
No, I'm just saying when you see your disk, it is like that. There is some memory filled, then it is empty, then it is filled, then it is empty, something like that. Your disk is there. But you want that contiguous memory location should be there. That means the filled memory should be in contiguous and in continuous thing, and the free memory should be separate and the filled memory should be separate. Do you understand?
Yes, ma'am.
So that is done by defragmenter. All the filled memory is taken care of separately, fragmented, and the free memory is fragmented separately. So that is defragmenter. So what happens is, suppose your file is of 2 GB, right? Your file is of 2 GB, and when you see the memory locations in between a file, there was space, but that space is 1 GB. Can you keep up in 1 GB the 2 GB file?
No, ma'am.
You will not be able to. For that reason, what you want is all the free memory should be separate, so that I can keep the file as the filled the file in free memory, and all the filled memory should be separate. That's why defragmenter is used. Right. So that is one thing. So then, what is data compression? You compress
Like
the
making
data,
a
zip
zip.
it. Yeah, you zip it. That means you are your file is of 1 GB and you wanted to make it to up to 50 MB or whatever. Less bit. So you are compressing the file. So you have different applications for that. Also, WinZip is one of the applications. Also nowadays, so you have online things also to zip it. Online websites also. Then disk management is I have shown you disk management also, right? Where you can see how much is your free space and how much CD drive is taking, right? In the manage. So that is this space. So they have shown you these are the maintenance things. Then you know about desktop. What is a desktop?
Where you can access the main page, the front page,
That
the
is
very
your
first page.
first page of your operating system, and which holds the icons, files, folders, and my documents, my computer, whatever. So that is your, and you can also change the background of your computer screen on the desktop, right? So you have my computer, my document, recycle bin, taskbar generally. Right? Well, this is a general point of view, but other things can also be done. So you should know what is my computer. Nowadays, my computer is not there. This is this computer, this PC now. You understand?
Yes.
Earlier computers were my computer. Now it is this PC. And then you have my documents, which is which you can keep it on the desktop. You have recycle bin also, and taskbar is also there. Then internet on a PC, you have two kinds of connections also. You have dial-up connection, dial-up internet connection, right? Earlier it was dial-up. Do you know what is dial-up internet connection?
Through cable or the hard one?
Yeah, through the telephone line. Right now, broadband is also working on through telephone line or fiber optic cable. But
it dialed a number and then connected.
Earlier you used to dial a number, right? Dial the number and then you used to connect to the internet, and the modem was there to convert your analog to digital and digital to that conversion, right? So what happens in a dial-up? The speed was very low, speed was less, right? Internet speed was less, and if by chance if your phone line rings in between and you pick up the phone line, the internet used to go off. You understand?
Yes, ma'am.
So that was dial-up
Yes,
connection.
ma'am.
But nowadays you have broadband internet connection. So what happens? You don't have to dial. This is not as dial-up connection. In contrast, here permanent connection is there to the internet. Your username password has been set in the broadband connections thing, and whenever you open your system, your router or modem, whatever is there for broadband connection, you on it, and internet is on for you. Right, and even if you have landline with that, even if you pick up the phone, the broadband connection will not go off. It will keep on working. Both the things will work. You can listen to the phone also, and you can work on the internet also. And nowadays, Fiber optic cabling, fiber optic that is FTTH broadband connections have also come faster, more faster, right?
Yes.
Do you know about proxy servers? What are proxy servers?
And mirror sites.
It's a
Not
copy
mirror
of
site actually. It's like masking your IP with someone else, so that it's like a VPN.
Various P3
Not,
connected.
no, you cannot say it
basically
is
it
like
is
a VPN. It is like a proxy server is like
a
if it
copy
is
of server.
filtering the data from outside to your server.
Yeah, like what VPN actually does, that's the same task what it does. It does not like
Generally,
directly shows you are accessing it, but instead of
it
channels it
Like
shows
firewall?
no, not firewall. Then proxy servers can also act as you can also limit some certain applications to your client, right? Some websites they cannot visit. You can do through proxy servers also. That can also be done. So it is between the client application and the web server. So you keep a proxy server to maintain the
And the
things of.
websites can also be, restricted by the main server too.
Yeah,
And
it can be restricted by the main server also.
okay.
Basically, we are providing a security cover to our web server. Directly, you cannot go to the server. You first have to you have to talk to the proxy server. Right? You are not directly talking to the server. You are talking to the proxy in between. So that kind of a thing.
Is it a kind of dummy server, ma'am?
Darby means what?
Dummy server means it's a mirror of the main server.
dummy server.
Dummy, okay. Dummy server. You can say that, but dummy server, you cannot say it is a dummy server. It's an intermediary between the client and the web server.
Okay, ma'am.
It's used basically to improve the performance and for filtering purposes and all that. Sometimes your applications require certain things, so you need proxy servers for that. So that's why. So they are just telling you that only about proxy servers. So this is what your last unit is all about. That is your unit 5 of block 1. So this was unit 1, 2, 3, 4, 5 of block 1. Right?
Yes, ma'am.
So any doubts in this? So we have basically finished block 1. We'll go to block 2. That will be Monday. So that I think that is about computer software, more elaborate things about computer software. So we'll talk about that when we come. We'll also talk about algorithm and flowchart in your this, right? So that will be Monday. So everybody has put their attendance, use their name and enrollment number in the chat box. Everybody.
Yes, ma'am.
Anybody left? Anybody left with their name and enrollment number?
No, ma'am. I have done it.
I done it now.